When sizing wire and breaker for a geothermal heat pump, several factors must be considered. These include the voltage, full load amps, minimum circuit ampacity, and maximum heating, air conditioning, and refrigeration circuit breaker size. For a 240 volts, one-phase geothermal heat pump with a 27.7 full load amps, a minimum circuit ampacity of 32.2 amps, and a maximum heating, air conditioning, and refrigeration breaker of 50 amps, it is essential to select the appropriate wire size and breaker to ensure safe and reliable operation. The minimum circuit ampacity of 32.2 amps dictates the minimum current carrying capacity the wire must possess. In this scenario, number 8 wire, rated for 40 amps at 60 degrees Celsius, exceeds this minimum requirement, while the maximum heating, air conditioning, and refrigeration breaker is 50 amps. It's important to understand how heating, air conditioning, and refrigeration breakers operate. Heating, air conditioning, and refrigeration breakers are designed to handle temporary overloads and inrush currents associated with motor loads. They are permitted to trip at currents exceeding their rated value, typically around 125%. Let's examine the properties of number 8 wire and a 50 amps heating, air conditioning, and refrigeration breaker to determine if number 8 wire is permissible in this situation. Number 8 wire is rated for 40 amps at 60 degrees Celsius. It is also rated for 55 amps at 75 degrees Celsius and 55 amps at 90 degrees Celsius. Since the maximum heating, air conditioning, and refrigeration breaker is 50 amps, it is allowed to trip at 125% of its rated current. This means a 50 amps heating, air conditioning, and refrigeration breaker can trip at up to 62.5 amps, 50 amps multiplied by 1.25. Even though number 8 wire is only rated for 40 amps at 60 degrees Celsius, it's important to consider the overcurrent protection characteristics of the heating, air conditioning, and refrigeration breaker. Since the breaker will trip at 125% of the load, number 8 wire, rated for 40 amps at 60 degrees Celsius, is acceptable for a 50 amps heating, air conditioning, and refrigeration breaker. It is important to consult the National Electrical Code, specifically Table 310.15. B16 for allowable ampacities of insulated conductors rated up to and including 2000 volts, 60 degrees Celsius through 90 degrees Celsius. Always follow local electrical codes and regulations. If there is any question, consult with a qualified electrician. To reiterate, number 8 wire is acceptable for a 50 amps heating, air conditioning, and refrigeration breaker in the specific geothermal heat pump installation, given the specified parameters. The minimum circuit ampacity is 32.2 amps, which means the wire must be able to handle at least that much current. Number 8 wire is rated for 40 amps at 60 degrees Celsius, which is greater than the minimum circuit ampacity. The maximum heating, air conditioning, and refrigeration breaker is 50 amps, which means that the breaker must not trip at less than 50 amps. Heating, air conditioning, and refrigeration breakers are allowed to trip at 125% of the rated current, which means that a 50 amps heating, air conditioning, and refrigeration breaker can trip at up to 62.5 amps. Number 8 wire is rated for 40 amps at 60 degrees Celsius, which is less than 62.5 amps. Therefore, number 8 wire is acceptable for a 50 amps heating, air conditioning, and refrigeration breaker. It's crucial to consider the specific operating conditions, local electrical codes, and manufacturers' recommendations when selecting wire and breaker sizes for any electrical installation. When working with electrical systems, safety is paramount. Always disconnect power before working on any electrical components, and if you're not comfortable working with electricity, consult a qualified electrician. Sizing conductors and overcurrent protection for equipment such as a geothermal heat pump involves several steps, including determining the minimum circuit ampacity and the maximum overcurrent protection device rating. The minimum circuit ampacity is calculated based on the equipment's nameplate information, while the maximum overcurrent protection device rating is limited by the equipment's listing and labeling. In this case, the geothermal heat pump has a full load amps of 27.7 amps and a minimum circuit ampacity of 32.2 amps. This means that the conductors must be sized to carry at least 32.2 amps continuously. The equipment is also marked with a maximum heating, air conditioning, and refrigeration type breaker rating of 50 amps. The question is whether number 8 copper conductors are suitable for this application, considering that they are rated for 40 amps at 60 degrees Celsius. To determine the appropriate conductor size, it is necessary to refer to the National Electrical Code and relevant industry standards. Firstly, the conductors must be sized to carry the minimum circuit ampacity of 32.2 amps. Number 8 copper conductors with an ampacity of 40 amps at 60 degrees Celsius meet this requirement. Secondly, the overcurrent protection device must be sized to protect the conductors and the equipment. The maximum heating, air conditioning, and refrigeration type breaker rating is 50 amps. Number 8 copper conductors are protected by a 50 amps overcurrent protection device, as the conductor ampacity exceeds the overcurrent protection device rating. Therefore, number 8 copper conductors are suitable for this application. However, it is important to consider other factors such as voltage drop, conductor temperature rating, and ambient temperature. Voltage drop should be calculated to ensure that the voltage at the equipment terminals is within acceptable limits. Conductor temperature rating should be selected based on the equipment terminations and the ambient temperature. If the voltage drop is excessive or the conductor temperature rating is not suitable, larger conductors may be required. It is also important to ensure that the installation complies with all applicable codes and standards. Always consult with a qualified electrician to ensure that the electrical installation is safe and code compliant. In summary, number 8 copper conductors are acceptable for this geothermal heat pump application, provided that the voltage drop is within acceptable limits, the conductor temperature rating is suitable, and the installation complies with all applicable codes and standards. Always prioritize safety and consult with a qualified electrician to ensure a safe and code-compliant installation. Remember that electrical codes and regulations can vary depending on the location, so it is essential to consult the local authorities having jurisdiction for specific requirements. The National Electrical Code provides comprehensive guidelines for electrical installations, but it is not a substitute for professional judgment and expertise. Always exercise caution and seek professional assistance when working with electrical systems. In addition to conductor sizing and overcurrent protection, other factors should be considered when installing a geothermal heat pump, such as grounding, bonding, and surge protection. Grounding ensures that the electrical system is properly connected to the earth, providing a path for fault currents to flow safely. Bonding connects all metallic parts of the electrical system together, minimizing the risk of electric shock. Surge protection protects the equipment from voltage surges caused by lightning or other electrical disturbances. It is important to select and install appropriate grounding, bonding, and surge protection devices to ensure the safety and reliability of the electrical system. Furthermore, proper maintenance and periodic inspections are essential for ensuring the long-term performance and safety of the geothermal heat pump. Regular maintenance tasks, such as cleaning coils and checking refrigerant levels, can help to prevent equipment failures and reduce energy consumption. Periodic inspections by a qualified electrician can identify potential problems before they become serious hazards. By following these recommendations, you can ensure that your geothermal heat pump operates safely and efficiently for many years to come. In conclusion, sizing conductors and overcurrent protection for a geothermal heat pump requires careful consideration of several factors, including the equipment's nameplate information, the National Electrical Code, and relevant industry standards. Always prioritize safety, consult with a qualified electrician, and comply with all applicable codes and regulations to ensure a safe and code-compliant installation. The information presented here is intended for general guidance only and should not be considered a substitute for professional advice. Always seek the assistance of a qualified electrician for any electrical work. The specific requirements for conductor sizing and overcurrent protection can vary depending on the specific equipment and installation conditions. Therefore, it is essential to consult the equipment manufacturer's instructions and the applicable codes and standards to ensure that the installation is safe and code compliant. Remember that electrical work can be dangerous, and it is always best to leave it to the professionals. If you are not comfortable working with electricity, consult a qualified electrician for assistance. By following these recommendations, you can help to ensure the safety and reliability of your electrical system. The goal is to provide a safe and code-compliant electrical installation that will serve your needs for many years to come. Always remember to prioritize safety and consult with qualified professionals when working with electricity. Number 8. Wire with an ampacity of 40 amps is suitable for the 50 amps heating, air conditioning, and refrigeration breaker in this scenario because heating, air conditioning, and refrigeration breakers are designed to allow for temporary overloads, accommodating the inner current of the motor without tripping prematurely. However, local codes and specific equipment requirements should always be checked.